we're going to differentiate e to the power of another function. So to do that, we'll just do e to the power of the function, differentiate the function, differentiate the power. Okay? So there's no explanation, we'll just use the rule. So let's start with the rule. So for the first question, you just differentiate the power, which is 2x, multiplied by itself. So it's very easy to do. Actually, I do want to say something. There is the formula sheet. So if you go to your formula sheet, this is on the formula sheet. So if you go to, yep, it's right there. That's on the formula sheet. So it's given. So if you forgot, you can always look there. Let's go back. All right, that's the answer. Differentiate the power times itself. Easy enough. Let's do the next one. Y dash 4 times 3 e to the power 3x. You differentiate the power 3x becomes 3 minus negative 2 e to the power negative 2x minus 2 times negative 1 e to the power negative x. And then make sure you simplify 12 e to the power 3x plus 2 e to the power negative 2x plus 2 e to the power negative x. Right, done. So you've got some simple ones, and then we'll look at some harder ones. So the next one, you have to use a different rule to do. You have to use the chain rule. So whenever you see a bracket, you use the chain rule. So it's like the question we just did today. You bring the power down, power 1, times by the e to the power 4x, so you get 4 e to the power 4x. Close that. All right, okay. Okay, good. And then you do 2 times 4 is 8 e to the power 4x. Do you need to expand? You don't have to. So you can leave your answer like that. Right, how about the next one? You may think it's a fraction. Let's use the quotient rule. But for this one, you don't have to, because you can just split it first. If you use quotient rule, it's going to be more work. If you split it, it will be less work. So if you split this, the first one, you get e to the power negative x plus e to the power x. Now remember, this is still y. We haven't differentiated yet. Then if we differentiate, it will just be one step. So if you compare that with a quotient rule, that will be a bit harder. Okay? All right, done. So remember to split. If you have one term at the bottom, you have one term, just remember to split. Okay? Now how about the next one? Next one, you have to use the product rule. Okay, let's use the product rule. So you like u equal to x squared cubed, v equal to e to the power 3x. And then you do u dash equal to 3x squared, v dash equal to 3 e to the power 3x. Okay? And you cross multiply, so u dash v, you get 3x squared e to the power 3x plus uv dash x cubed times 3 e to the power 3x. You will notice that there is a common factor of e to the power 3x as well as the 3. So you take the 3 out and the x squared, e to the power 3x, and you're left with 1 plus x. Yep. Done. Product rule. How about the last one? Can you split with the last one? You can't split. See, the first one you can split, but this one you can't. So what do? You use the quotient rule. So you call that u, call that v. You cannot split when there are two terms. So you have to use quotient rule, whereas this one, you can split. You don't have to use quotient rule. This one you do. Let's write them down. U dash equal to e to the power 2 e to the power 3x. V dash is e to the power x plus 3 e to the power 3x. Like that. And then you just use the quotient rule, which is equal to u dash v. V is this thing minus u v dash over the denominator square. So that one's pretty long. So you can see the quotient rule can be very long. Square. All right, now you just have to expand this. Expand. Like that. Expand. right? Expand this. So make sure you use your index law. So the first one will be 2 e to the power 3x, because 2x plus x is 3x, plus 2 e to the power of 5x, 2x plus 3x is 5, minus e to the power 3x, and then minus 3 e to the power 5x, all over the square of the denominator, which you do not need to expand. Just keep it like this. And then what do you do next? You can subtract things. They are like terms, so these two are like terms. So you get e to the power 3x. And then these two are like terms. You get negative e to the power 5x. And at the bottom, you get something square. And you leave it as a square. Okay? Alright, good. So we give a full page. Alright, have a look. Alright, hopefully all done. Before I move on to the next page, 3 more questions, then we're done with the equation of normal. Some simple questions, and then you can do the homework. Alright. All done? Yep. Next. Right, find the equation of normal. So what do? Differentiate first to find the gradient. So we do y equal to e to the power 2x minus 3x. Y dash equal to 2 e to the power 2x minus 3. And then after that, you have to substitute the point. Now the point is 0, 1. So you substitute the x value 0. So the gradient of the tangent equal to 2 e to the power 0 minus 3. E to the power 0 is 1. 2 minus 3 equal to negative 1. That's the gradient of the tangent. Then we find the gradient of the normal, which is the negative reciprocal of the gradient of the tangent. So you get negative 1 over negative 1, which is positive 1. So that's the gradient of the normal. Once you get the gradient of the normal, you use the formula y minus y1 equal to mx minus x1. x1, y1 is the point that you just have. So you do y minus 1 equal to the gradient x minus 0, y minus 1 equal to x, and then y equal to x plus 1. That's the equation of normal. Right, done? Good. Okay, next one. Example 8. Find the first and second derivative. Pretty easy. E to the power x squared, first derivative. You differentiate the power, which is 2x, e to the power of x squared. Okay? Now, what happens if you find the second derivative? Second derivative. Second derivative is you have to use the product rule. Like that. And then you're going to, so be careful, the first one you don't use product rule, but the second one you do because of the extra x in front. And then you're going to differentiate, which is 2 e to the power of x squared. So write u equal to 2x, v equal to e to the power x squared. And then you write plus u, which is 2x, e to the power, and then you have to differentiate, which is 2x e to the power of x squared. So 2x e to the power of x squared. Okay, so that's 2. Right, so we're going to simplify that. You get 2 e to the power x squared plus 4x squared e to the power of x squared. Okay, and if you want, you can factorize. So you get 2 e to the power of x squared 1 plus 2, oh, pen doesn't work, 1 plus 2 x squared, like that. Alright, any questions? Okay, so just be careful after you find the first derivative, the second derivative requires you to use the product rule because you have an extra x there. All right, we've got one more question to go through, then we're done. Example 9. All right, this is the question we did yesterday, except it's a little bit harder. You have to show this is true. So how do we show this is true? We find the first and second derivative. So starting with y, find the first derivative, which is negative 15 e to the power negative 3x. And then second derivative, you get negative 15 times negative 3 is 45 e to the power negative 3x. And then we have to substitute into this equation. So we start with the left-hand side, second derivative plus the first derivative plus 3y, and we substitute. So we substitute this in there, which is 45 e to the power negative 3x. And then we go plus 4 multiplied by the first derivative, and then finally plus 3 times the y. The y is 3 times 5 e to the power negative 3x. And what you need to do is to simplify it. Minus 60 e to the power negative 3x plus 15 e to the power negative 3x. And if you collect like terms, these two minus to get negative 15 e to the power negative 3x plus 15 e to the power negative 3x, which becomes 0. And 0 is the right-hand side. So we showed that it worked. Okay? So right there for, yeah, so we show. Okay. All right, that's done. All right, so today you just do exercise 4.2. And make sure you finish yesterday's exercise 4.1. And next lesson you do integration. All right, done. All right, get a textbook.